Hello, today we are going to do a video on multi-step equations, kind of some basic multi-step equations. And these were some issues that we've had throughout the year. So these problems that I've selected all have a little trick to them that some of us had struggled with. And this video goes along with the multi-step equation worksheet that you'll see in Google Classroom, as well as the multi-step equation Google quiz that you'll see once you feel you're comfortable with this material. But again, I want to go over just a few problems that I thought have given us some issues throughout the year. So here's the first one. And the biggest issue with this problem, there's two actually. One, we have the variable on the right side of the equation, and that's been a little bit of a struggle for some of you. And then more importantly, that the variable term is negative, okay? And so what most of us do when we do this first step, when we move the 7 over to the other side of the equation, is we just lose that sign. When you bring down the 5n, you got to bring down the negative with it. And actually, that reminds me of another issue some of us have had throughout the year, and that has to do with the sign of this guy right here. This is positive 7, so to move it to the other side, we need to subtract 7 from both sides. All right, I've seen a lot of kids this year add 7. Remember, 7 plus 7 is 14, not 0. We need these to cancel out. We need this to equal 0, and 7 minus 7 is 0. So that leaves me with 45 equals, and again, here is the other issue here is when you bring down that 5n, you got to bring down the negative 5. All right, bring down that negative symbol so that when you divide both sides by negative 5, you're not losing that negative. Negative 5 divided by negative 5 is 1n, which is exactly what we want here. And 45 divided by negative 5 is negative 9. All right, so that was just one example of a few issues you've had. Hopefully, when you come across this problem now, it'll be a little easier to manage. All right, problem 2. There's a couple ways to think about this problem. I'm actually going to solve this 2 different ways. Okay, so the first one, I'll rewrite it here. It's probably the way I actually like to think about the problems. So I'm going to add 7 to both sides. That really doesn't change. 3/4 x equals 12. And then when I like to kind of finish these problems, one way I do it is to, instead of multiplying by the reciprocal, I just want to move this 4 out of the denominator to the other side of the equation. I'm going to multiply both sides by 4. And 12 times 4 is 48. And now I want to divide both sides by 3. This is kind of a little more comfortable way, maybe instead of finishing that 3/4 in one step, we're doing it in 2. Might be a little more manageable for some of you. And 48 divided by 3 is 16. All right. So let's take a look at the problem in a slightly different way. So we're still going to copy the problem the same way. We're still going to add 7 first to both sides. And now we're going to multiply both sides by the reciprocal. So it's essentially taking what took us 2 steps on this side and just finishing it in 1 step. Okay. One way that's nice about this is we can divide first to make the numbers a little easier. So 12 divided by 3 is 4, and 4 times 4 is 16. Or we could do 12 times 4 is 48, which is exactly what we had right here. Then divide it by 3, and we still get our 16. I like to kind of make the number smaller initially if it comes out nice, and this does. 12 divided by 3 is 4. 4 times 4 is 16. And again, if you want to use a calculator for that, you can. I just wanted to show you 2 ways to look at a very standard reciprocal problem, or where our coefficient is a fraction. So 2 ways to handle it. All right, the next problem. Again, there's really not much difference between this problem and the last problem. The only difference is our variable is kind of tied to our numerator, but this is still 2/3 b plus 6. It's the same exact thing. All right, this one lends itself a little easier to multiplying by 3, then dividing by 2 after we move this 6 over. So I'm going to show you that. So I subtract 6. I get 2b over 3 equals 18. I'm going to multiply, in fact, I'm going to do the reciprocal here again. I'm going to multiply both sides by 3 over 2. Again, if you understand that this is also 2/3 b, they mean the exact same thing. Okay, then you see that you can still use a reciprocal here. And those cancel out. 3 divided by 3 is 1. 2 divided by 2 is 1. That leaves us with just b, which is exactly what we want. 18 divided by 2 is 9. 9 times 3 is 27. Okay. One of the reasons why I wanted to use the reciprocal here is so I could divide by 2 first, which makes this a little easier to manage. I really wasn't looking forward to do 18 times 3 and then divide that by 2. It's not a terrible problem, but still, it's a little easier this way. All right, on to the next. Same idea here. This is 1/5 y. Y over 5 is how the problem has been presented to us. So in this problem, we want to add 6 to both sides. Notice that in all of these problems, we're kind of leaving this variable term alone until the last step. That leaves us with y over 5 equals 14. And it's not by accident that these are both numerators, y and the 14, and they're kind of across from each other. My denominator is clearly below everything else. That way I'm getting this idea of when I want to move this 5, he's in the denominator, I'm going to multiply both sides by 5. These cancel out. 5 divided by 5 is 1. That leaves me with just y, and 14 times 5 is 90. All right. So again, those were 3 of the essentially the same problem written in a slightly different way. And I just wanted to prepare you for all 3 of those because throughout the year, again, some of us have had just, small issues with each of these. And it's not the same people. Some people don't like, this version 3. Some don't like the middle version, like 2b over 3. So just trying to convince you that they're really all the same problem. All right. And then the last one, what I call the big fraction problem. So I have a big fraction bar. X over 5 is the entire thing is being divided by 3. So instead of adding 5 first, we can't do that because that would violate order of operations. We need to, what I mean by that, because I got some time, is if I knew what X was, let's say X was 6, I would have to do 6 minus 5, which is 1, and then divide that result by 3. Okay? And when we solve equations, we undo order of operations. So if the first thing I'd have to do is subtract 5, and the second thing I'd have to do is divide by 3, then to undo all that, I'm going to have to multiply by 3 first, then add 5. So reverse order of operations. All right. And again, big fraction, if you're just trying to get through this, big fraction, we're going to multiply both sides by 3 first. 3 divided by 3 is 1, so that gets rid of that 3 and it moves it over here. So I'm going to rewrite the numerator. Okay. And then I'm going to add 5 to both sides. And that is really the kind of the other problem we've had in this section throughout the year that stumped some of us. So I hope this video helps. Stay safe. We'll see you guys next time.